Okay, we are going to review for the Prealgebra Chapter 9 test. Anyway, this is the practice test, and I have a drawing here of a line with a ray coming off of it, and there are points A, B, C, and D on this figure. So anyway, let's look at the questions related to that. Name the following in the above figure. Number 1, name 4 points. Well, when you name points, you use capital letters for points. So there's points C, D, B, and A. And then name 4 line segments. Notice a line segment is indicated by a line above the 2 end points. And I've got those listed there. Rays are indicated by a line with an arrow at one end. Okay, so you can see the rays listed there. All right, our next set of questions deals with this figure, and notice it says A is parallel to B. So line A is parallel to line B. And then this is called the transversal line, the line that goes through both of them. Okay, so name all the angles congruent to angle 3. So congruent means the same measurement. So the angles with the same measurement would be 3 and 4 and 6 and 8. And so that's represented. Angle 3 is congruent to angle 4, angle 6, and angle 8. Okay. Number 5 is name all the corresponding angles. What's the meaning of corresponding angles? Same side of the transversal in corresponding positions. So here's our transversal. So on the left side or on the right side. So on the left side, angle 1 and 5 are corresponding angles. Angle 4 and 8 are corresponding angles. Then on the right side, angle 3 and 6 are corresponding. Angle 2 and 7 are corresponding. Okay. Number 6, name 2 pairs of supplementary angles. Okay, what supplementary mean? It means 2 angles that share a side and their other side lines up with a line. So this is the shared side for angles 1 and 3, and they share the same line. So 1 and 3 are supplementary. And then underneath it, on this same line, angle 2 and 4 are supplementary, angle 5 and 6 are supplementary, angle 7 and 8 are supplementary, but then you could look at it kind of sideways with this line. Angle 1 and 4 would be supplementary, angle 3 and 2 would be supplementary, angle 6 and 7, and then angle 5 and 8 would be supplementary. So lots of ways of looking at it. And I didn't have room to write it all in there. Okay, so lots of possibilities. You just have to name 2 of them. Okay. Use the most precise name for the figure described in 7 through 10. A parallelogram with 4 90-degree angles and 4 congruent sides. Well, that sounds like a square. A triangle with 1 angle more than 90 degrees and all sides are different lengths. So that would be an obtuse triangle, and with all the sides different lengths, that would be scalene. Okay, a figure with 1 pair of parallel lines and has 4 sides total. That sounds like a trapezoid. Number 10, a triangle with all sides congruent and all angles less than 90 degrees. All sides congruent, that would be equilateral. That means all sides are the same measurement. And then all angles less than 90 is acute angles. Okay, on these 2, I left off the letters for the corner points. So fill those in on your worksheet, and that way you can better answer the questions. For the above 2 triangles, list the congruent corresponding parts. That would be A in your answer area. And then write a congruent statement and reason, part B. Okay, so I have listed all the congruent parts. Segment AB is congruent to DE, and so on. So you can look at those. Now, a congruence statement. We can say triangle ABC is congruent to triangle DEF, and that would be because of the side, angle, side. And notice side, angle, side. In other words, this side has equal measure to that side, this angle has equal measure to that angle, and this side has equal measure to that side. So side, angle, side, that's a theorem that says these two would be equal if you have two sides equal and one angle in between those two sides equal. Okay, but with this same figure, we can also say that those two triangles are congruent because of side, side, side. Now what does that mean? All three sides have a corresponding equal side. So this one's corresponding to that one and equal, or congruent. And this one's congruent to this one, and this one's congruent to this one. So when you have all three sides corresponding to a congruent side, then those triangles are equal for that reason. However, we have a third reason that's identified here, and that's angle, side, angle. And so when you have an angle corresponding with another angle over here that's equal, a side in between that angle and another one that's congruent, and then the other angle at the other end of that congruent side that's congruent to the other one, then they're equal. Okay, so that's our reasons for it. Now, number 12, find the circumference of the circle with the given diameter or radius, and then use 3.14 for your pi. Remember, 3.14 is a rounded number. All right, now here are our formulas. Circumference equals pi times diameter, or 2 times pi times the radius. Okay, so if your radius is 45 millimeters, all you're going to do is take that and plug it into the correct formula. It would be this one. So 2 times pi times the radius, and you get 282.6 millimeters. Don't forget to add your unit on the end. Your diameter is 83 centimeters. So 3.14 times the diameter, and you get 260.62 centimeters. Choose the angle that is the closest match for the degrees in the figures below. Okay, so let's do the easy ones first. 180. 180 degree angle is a straight line, so that's B. We know a 90 degree angle, we call it a right angle, is easy to identify, so this one would be A. Okay, so we've got the two easy ones out of the way. All right, we've got 3 left. Well, obtuse means an angle that's greater than 90 degrees, so D is 135, so now we're down to these two. Okay, 45 degrees is a little more than 30. Well, this one looks a little larger in its angle, so this one would have to be my 45 and that one my 30. All right, 14. Find the area for the below triangle. Well, our area formula is 1/2 the base times the height. Remember, if you had a rectangle, so if you had the other part of this, it would be, area would be length times the width. Okay? Well, this is only half of a rectangle, so that explains why we have to do 1/2 times the base times the height. We could just say length times width as well. 1/2 that, and there's your triangle area. So I've shown the math here, and I didn't put any units here, so remember, whatever unit it is, you would square that unit in the answer. Okay, so 15. 15 wants you to just say what 31.2 centimeters is in millimeters. Well, there are 10 millimeters for every centimeter, so you'd multiply that by 10. It would be 312 millimeters. Name the solid shapes. this shape is a cylinder, and this shape here is a cube. And just ignore that extra line there. I meant to white it out and forgot to. So, all right. Number 17. Look back to the first page at the line shown in the diagram above 4. At the lines. So in other words, here's 4. So in this figure here, and what's our question ask us? It says in that figure, identify the alternate interior angles. Okay, so the definition of interior is inside the area between the two parallel lines. So these are our two parallel lines. An alternate interior. So 2 is the alternate interior angle for 5. They have the same measure when these are parallel. 4 is the alternate interior for 6. Okay. Number 18, I really messed up my drawing here in the middle. And I even wrote there, drawn wrong. But I realized that after I did this worksheet. This was supposed to have a right angle here. I just totally messed it up. So I redrew it, and it should have been a right angle, and this indicates 3 different length sides that was scalene. Okay, this one, all 3 sides are equal according to these tick marks, and you can tell that the angles are less than 90, so it's acute and equilateral. Equilateral meaning all the sides are the same. Okay, this one is a 98-degree angle. That's obtuse. 2 sides are the same, so it's isosceles. Okay, 19. Suppose you want to make a pie graph for the chart below. What would be the measure of each central angle to the nearest degree? So remember, a pie graph or circle graph. Circle. Circle has how many degrees? 360 degrees. Okay, I tell the kids to remember your bike lingo. If a guy pulls a 360, he's turned his bike all the way around and landed it straight again. So 360 degrees is the degrees for a circle. If we're going to do a pie shape, we need to know the equivalent for 42 chocolate ice creams, 21 vanilla, 13 peach, 12 chocolate chip, and 10 orange creams. And this would be the number of students that like those ice creams. So first you want a total. Okay, then you want to use proportion to set it up. So I put a little note here. So your number of chocolates to the total is like the pie section to represent the chocolates, those degrees, to the total degrees. Okay, so that's your proportion. You cross multiply. 42 times 360 equals 98 times x. And then you get x alone. So if it's being multiplied by 98, you do the opposite to both sides. Divide by 98. So it ends up being 42 times 360 divided by 98. You get 154 degrees. So you're going to do that for every one of these. Set them up like proportion. 21 times 360 divided by 98. 13 times 360 divided by 98. 12 times 360 divided by 98. And you'll get all these degrees. Now, I had to round those to get whole degrees. Notice this one came out 1.54.3, and even that was rounded. It actually went on. So I rounded it to 154 degrees. So I have a nice even pie chart, easy to make. And those do add up to 360. Okay, hope this helps you for the test. Remember that you should use your textbook. It has instructional videos for anything you really don't understand. You should read your textbook, and then you have practice quizzes noted at the bottom of your textbook page that you can try online. And those let you know if you're ready. They're usually quick, so I recommend you do all those things to prepare. Thanks. Bye.